Hi, I'm Deborah Fowler, and I'm going to introduce Python inside of Houdini and outside of Houdini. So we're going to take a shape, a planar shape, write out that file, and then read it in for the purposes of drawing in Turtle. So if you're familiar with Python Turtle, essentially what we're going to do is take that file, open it up in Python, and draw the same circle that you're seeing in my Houdini session. Now, it doesn't necessarily have to be a circle. It could also be a maple leaf. Or alternatively, it could be whatever 3D shape that you want using a trace node. All right, so let's dive inside. So to start, I'm going to use a fresh session of Houdini, and I'm going to bring in a geometry node or container, which is on the objects level, your main level, dive inside, and create a trace node. And this trace node comes up by default with an image called circle.pick. And that gives me geometry. As you can see, I've got a lot of dots, a lot of points. That's a little bit too complicated for what I want, so I'm going to resample. And that will reduce the number of points. That's not bad for what our purposes are for Turtle. We're going to add an add node because really I just want point information. So that deletes the geometry but keeps the points. So now I'm ready to start looking at what it will look like when I get to Turtle. So I'm going to use this add node. I'm going to call this add preview because this is going into polygons, going to join the lines to make sure that everything is in the right order. I display that, and you can see that it's joining as I want it, but at the bottom there's a gap. So what I need to do is I need to duplicate that point. So I'm going to do that also with an add node. So in this add node, I'm going to create a point, not at the origin, but I'm going to duplicate the very first point that we had. So all I need to do is use the point function in HScript and reference add1, which is the node above. And then I'm going to grab the 0th point, grab the point information or attribute, and in this case I want the x component. Grab that expression that I've just created, paste it into the other two fields, and I'm then going to change this to the y component and the z component. And you can see that now it's in the correct place and we have a closed circle. Awesome. Now the other thing I know is that in Turtle, my coordinates aren't going to match to Houdini. So I'm going to use a transform node and I'm going to scale this up to about 300 units. So now I have a circle, hit space G so I can still see it. I'm ready. I'm going to create a Python node at this point so that I can write this out to a file. So in here, I created a Python node. I'm just going to delete this. You can see that this code is added to give you information. So this is identifying the present working directory or the Houdini node where it lives. In other words, its current place. And this is a geo, which is identifying the geometry in that node. So what we can do is we can say for point in geo.points, grab the point information, and what we're going to do is iterate through there. So the first thing we're going to do is grab the position of that point. And we're going to write that out. So we've got now the position. We're going to create a string. So this string is going to be grabbing the x position, which is the 0th component of that vector, plus the y position, plus the z position. Okay, but the problem right now is that's going to add numbers, and we don't want just one number. We want a string. So convert these numbers to strings, and we can do that by using the string function. So the string function takes on one argument, and it will convert what we give it into a string literal. Okay, so that gives us a bunch of strings, but they're all going to be concatenated together without any spacing between them. So I'm going to add in here a comma. And the reason I'm using commas is because that's similar to an Excel sheet, and you can dump out an Excel sheet comma delineated. So I'm using commas. And then in here, I'm going to add a new line. In other words, character to indicate that I want it printed on a separate line. Okay, so I now have a string. Let's take a look at that string. So in here, you can see that I'm printing out point information. So far so good. You can see that the first point is mimicking, there's the top point, mimicking the bottom point because we did that in our add node. And let's actually go in here and relabel this add first point, just so that when we come back, we know what's going on. Okay, so in here we have our Python file, our Python node, if you will, but we've only printed out to the console window. That's not good enough. We need to print it out to a file. So at this point, we need to create one. Well, we know how to do that in Python. It's the same thing because this is just Python inside of Houdini. So I'm going to call this file pointer. And I'm going to create a open. Here's my file, name of the file I'm going to create. And this variable is going to be keeping track of where that is. And then this is going to be for writing, because we're actually writing it, not reading it. Okay, so now we've opened a file. And we're going to make sure that anytime you open a file, at some point you want to close it. Now we've got a file. Okay, great. But we haven't written anything to it. So I'm going to go ahead and create some information in there. So I'm just going to say, hello, this is a point. Okay. And then I'm going to also write my point information. And I don't need to write to the console window, so I'm going to get rid of that. And let's go ahead and test this. So we now just wrote test.txt, and that is going to be sitting on the top level of my directory, which it is. So if I look in here, and I'll look at that, it's got information, as I would expect. I've got my first and last points matching, and it's got a whole bunch of information in between. Okay, so let's actually write a Python file so we can bring that in. So I'm going to bring up idle. You can bring up Sublime or Genie or whatever IDE you happen to be working in. I'm going to create a new file, and I'm going to save this in my folder. So rather than the default folder, I want it over here because I want to be able to access my file easily. And I'm just going to call this test.py. Save. Okay. So the first thing I'm going to do is import turtle. And because I don't like typing a lot, I'm going to set turtle to be T. And then I'm going to open my file. Well, much like we opened the file over there, we're going to open the file here. So let's create a file variable. And that's going to be equal to open test.txt. We're still dealing with that same thing, but rather than writing it, here we're reading it. Okay. And for line in file var, let's print that line. Okay, so we're opening the file, and if we run this, we can see that we're getting exactly what's in our file. Great. So now what we want to do is be able to access information in there, but these are strings. So what we need to do is massage this. So let's call it myList, and we're going to do a split function on that list. If we just split it by default like this, it's going to use spaces, and that's not really what we want. So let's actually print our list here. So if you look at this, what happens is we've got hello, this is a point, blah, 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 right? Which isn't really what we want, comma. What we really want is to have our values split on commas. So the way we do that is we just do comma as the argument. And now when we write this out, we should get the intended splitting, which is hello, this is a point, and then our information, our three information. But you'll notice here there's this \n. Now in our case, this isn't going to harm us because we're only using x and y, not z. But let's get rid of that anyways, just in case we want to use it for something else. So let's do rstrip, and it's a function that will get rid of extraneous characters. So if we run this now, we see that we no longer have the \n. Awesome. Okay, we're ready. So this is string information. I'm going to go ahead and assign x position equal to myList And we want not the 0 first, but we want the second value in our list. And we also want to create that from a string into a floating point number. And we want to do the same with y, so save myself some typing. Control C, Control V, and change this to y, and change this to 3. And now that we've got it in the proper format, we can do set position, x position, y position. And let's go ahead and run that. And you can see that we're getting our circle, but we're also getting this line in here. Very simple way to get rid of that. Let me just get rid of this print statement as well. What I'm going to do is before I get into the loop, I'm going to pick up the pen, and not until I've drawn one point am I going to put down the pen. So that way it'll move into position and then continue on drawing. And there's other ways you could do it. You could signal it as going in first. So you can see that it's drawing whatever points that we've done. If you want to see it more obvious in point, let's just do a turtle dot dot. Do that 20 units big. And run this. And you can see that those are our data points corresponding to our Houdini file. So that's the process. So you're using Python on both ends, both in Houdini and in Turtle. Okay, so what if you wanted to create a more interesting shape? Well, you just substitute out in your trace node. So let's go ahead and do that. Let's go ahead and grab the maple leaf. And then here, let's find it. There's our maple leaf alpha. That's a good one. Okay, so there's our maple leaf. And you can see we're going through the process. And when we preview it, we got this weird connection that we're going to have to take care of. But first of all, that's not a good enough estimation for me. So I'm going to change the resample value to be a little bit more detailed. And then in here, I'm deleting my points. I'm adding back the first. But before I add back the first, there's one other thing I want to do, which is get rid of that problem. So if you look at the preview over here, let's just grab that preview and just put it over here so you can see what's going on. It's adding the very last point to the first, and that happens to be, in this case, up here. What I'm going to do is add a group expression to get rid of that. So I'm going to grab the last point, which I'm going to change this to points, and I'm going to change this. I'm going to use a little vex. I'm going to change this to say if the point number is equal to that last point, which is the point numbers, the total number of points minus 1. So if you have n points, you have 0 through n minus 1 because we always start at 0. And then I'm going to delete that. Let's go ahead and delete that, and we'll say points, and we'll grab that group, which is group 1, and now it's correct. Okay, so just one little addition, and let's go ahead and grab that add point in here, and let's tidy it up by hitting L for line up. So we now have our preview down here. Let's grab that out and put it at the bottom because we don't actually want that in our file. And that way we can see there's our maple leaf. After it's been resized up, we're going to dump that out into Python, and that is our preview. So now we have our maple leaf. Let's go ahead and test that. So let's grab our node again and run this. And you can see our dot's super big, very, very big. Let's change that. That dot's a little too huge. And in fact, let's just get rid of the dot altogether by commenting it out. And then run. And then we can see that we're getting our maple leaf as we'd expect. And you can take any shape, create a alpha channel map or a black and white image, whatever brings in the geometry in its best form, and create an outline of that. So the other thing I want to show you are, right now, this is okay, but we could do a little bit more to clean it up. We could also have, instead of putting this into the top level, it'd be much better if it went into a folder. So let's create a little more sophisticated scripts. So over here, the first thing I would do is I would encapsulate everything into a function and tab it over. so that everything was properly set up. And I could also have a input that brought this in. I could also maybe do t.exit on click, so when I run it, it doesn't just disappear, and so on and so forth. So this is just a nice little cleanup of this function. So now we have a little function, draw this. We'd still have to send in a parameter with the file name and so on, but it's a little cleaner than it was. Over here, what we want to do is create a file so that instead of saying open test.txt, we can say some folder. Okay, so in this case, data. And that happens to be still my circle because I happen to have a value in data folder called test.txt. But what if I didn't have that? What if I wanted to create it, put it in there? So let's create another directory. Let's call it Kermit. So in that folder, right now, there is no folder, and it's going to give me an error, which I would expect. Okay, but that's waiting for me. What I'm going to do is over here, I'm going to create that folder. Something that we can do by importing a library called OS. So what OS does is it allows us to use command line control. So for example, let's just open up a command line prompt. And in here, let's grab this path, because that's where we want to be. We want to be in, actually we want to be up one level in here. We want to be in this folder so that if we wanted to create a folder, right, new folder. Okay, so now we have a folder. That you're used to. But what if you wanted to do it command line? So let's copy and paste this. So I'm going to cd or change directory into there, but it's on a different drive, so I have to make sure I'm in the right drive. So now I'm in there. And if I do make dir, and let's call this Miss Piggy, you can see that now I have a Miss Piggy folder. So make dir is a command that we use to make a directory or make a folder. Okay, so let's do that in here. We can do os.makedir, and let's call it Kermit. Okay, so now I have my Kermit, and if I look in my folder, I can see I now have Kermit. So awesome, it worked. But there's a problem here. So if I try and use this, it's going to give me an error. And the reason is it's trying to create that directory again. So there's a number of ways we could deal with this. We could delete it and recreate it. We could rename it. I'm going to use something called try except. So in here, I'm going to check first to see if it exists, and then I'm going to try and create it, and I'm going to handle the error. So let's go ahead and do that. If it doesn't exist, then try. And I'm going to have an except clause. Okay, so now I'm back, and Kermit is created, and the file is in there, and we're good to go. So I'm now happy. All right, so the next step is to reference that file from idle. So let's go ahead and do that. Back into our idle file, which is over here, and test it. We'll bring up idle, and we're now referencing Kermit. We run this, and you can see that it is working. Now, another thing we could do is we could add user-defined controls so we don't have this hard-coded. So for example, if I wanted to change the name or the directory name, that would be much simpler. Just for purposes of showing you that this is indeed working, let me grab something that we don't have yet, which is maybe leaf. So let's grab the leaf shape. There we go. And now you can see that we have a different file we're writing out to our Python, and let's take a look at that now. So I'm just going to bring up my Python code and run this. And you can see that now we have our leaf shape. Okay. So the beauty of this is that we've set it up now so that it creates a folder, keeps things neat and tidy. Two other things that we could add to this to make it a little more general is to go up to the top level and create some user-defined parameters. So in this case, I'm going to grab a file, and let's grab one over here and one over here. As long as I have them file type, I'm not really worried about what I'm storing in them. They're just going to be a string, and I'm going to call this one a dir name, or directory name, and this one's going to be file name. And apply accept. So now I have two parameters that I can add. Let's do directory name as new data, and let's do file name as let's see, kermit.txt. Now I could also say I could put this into the context of Houdini and where it is located. So I could also say $hip, and that would be a little cleaner. For right now, I'm just dumping it out into a folder, and this is local to my hip file. But if I move this around, I might want some place where I'm using the whole directory name. All right, so now we have a directory name and a file name. Let's go in here and grab that information. So we're going to call, same thing, directory name, but we're going to use the parameter that we just created. So we're going to do who.eval param, which is a function that I can use, and I can grab up above my top level. I have something called directory name, and that's going to evaluate that and give me that name. And then I'm going to change this from a hard-coded value to a parameter. And this allows me to make a more general version, just like we add parameters to functions. Right now we're adding a top-level control that we can now control the directory name. And here I'm just going to create an intermediate file just so that we can see it's a little clearer. Let's say file name is equal to who.eval parm ... file name. And then input file is going to be equal to the directory name plus a slash to divide it out, plus the file name that we've just put in. And then we're going to call that our input file, or maybe a better name would have been for me to call it output. So let's call this out file instead of in file. Okay, so that gives us a little bit cleaner setup, because in here now you can see that I have new data, and here I have kermit.txt, because that's what I've named it at the top level. And that gives me a lot more ability to manipulate this when I decide to create a leaf shape. So let's change this to leaf shape instead, because that's a little better a description of what is in here. Let's just call that leaf. Now I have a file that's being dumped out as leaf.txt, and that way that makes a little more sense than just test.txt. And I'm not overwriting it each time. I can change it very quickly without having to change anything in the code, but just at the top level. So that makes it a little easier. My directory name is called new data. And I could also change this over here in my Python script so that that was being read also from a input. For right now, I'm just going to leave that there. And you can see that I have my little leaf shape coming in from my file. Okay. So that's a little bit of Python inside of Houdini and inside of Turtle idle, I guess, inside of idle. But really, it's just Python. So Python reading and opening files, writing and opening and writing files. And there's one other thing I would like to add, which is there's another language as well, and that is a point wrangle. So let's go back to our trace node and grab just that simple circle. So the circle is actually living in this file folder. And you can see there's my circle. We had resample set to the default. So there's my circle. We have a unnecessary set of nodes in here where we're deleting the last one. So I'm going to get rid of that. It's only necessary for the leaf. I'm going to line these up a little more tidy by hitting L. And now you can see we're back to where we were with the circle. What I want to do now is, instead of doing that add first point with a H script expression, we're going to see what it looks like in wrangle. So this is using something called point wrangle. So I'm going to use a point wrangle node, or an attribute wrangle, which is really what it is. You can see right here it's an attribute wrangle. And instead of running over all the points, we're going to run it in details only, because we want to create one point. So what we're going to do is we're going to grab that first point, so it's a vector of 3, and we're going to use the point function. But in this case, the point function is a little different. We're going to grab the op input 1, which is the first input into that node. We're going to grab point information, but we're grabbing the 0th point, and that's going to return the entire point vector. Then we're going to add point to this particular node with that information. So it does essentially the same thing, and I'm just going to bypass this so you can see that we are again adding that point the same way we were doing it over here. But this syntax is using H script point function. So it's a path, the point number, the attribute, and the element. This one over here is doing the same thing, but we're using the point function inside of vex, adding the first input, the 0th point, so it's from where, the attribute, and in this case, it's which point number, because it's returning the entire vector, so the XYZ in vector format, and we're just adding point that way. Thank you for watching. I hope you've enjoyed this, and I'll see you again. Bye for now.